Hello friends, let us now learn some important points about the luminescent screens. So, in the luminescent screens, first X-ray photons which make up the important diagnostic radiological image cannot be visualized to the human eye. So, this information is to be converted into a visual image by two methods. One, by the usage of photographic emulsion. So, when a photographic emulsion is exposed directly to the X-rays, more commonly the energy of the X-rays is converted to the visible light spectrum. So, this visible light spectrum may be used to expose the X-ray films, which is seen in radiography or photofluoroscopy, or sometimes this visible light spectrum is viewed directly as in fluoroscopy. The sensitivity of the film to these direct X-rays is low. Direct exposure of the film would require large patient X-ray doses for most of the examinations. Therefore, almost all radiological film examinations require the radiological image to be converted into light by usage of luminescent screens, which we will see in our coming classes. So, first let us learn about fluorescence. So, and luminescence. First, luminescence. Luminescence refers to the emission of light by a substance. It is caused by various kinds of stimuli like light, chemical reaction, or ionizing radiation. The second term, fluorescence. Fluorescence is applied to that form of luminescence produced when the light is emitted instantaneously. Instantaneously meaning that it is emitted within 10 to the power of minus 8 seconds of stimulation. Then the second term is phosphorescence. Phosphorescence is emission of light is delayed beyond 10 to the power of minus 8 seconds. That means if the light is emitted instantaneously, that is within 10 to the power of minus 8 seconds, then we call it fluorescence. If the light is emitted more than 10 to the power of minus 8 seconds, then we call it as phosphorescence. So, this fluorescence is used in diagnostic radiology. So, the fluorescence is the ability of the tissues of certain inorganic salts to emit light when excited by the X-rays. So, when excited by the X-rays, the crystals of inorganic salts will emit light rays. So, this process is called as fluorescence or phosphorescence. So, the crystals which are used here is calcium tungstate crystals, and calcium tungstate crystal is the phosphor which is used in intensifying screens. Actually, this is fluorescence. Okay, this process is fluorescence, and the crystals used in this process are called as phosphors. So, the zinc cadmium sulfide is a phosphor in fluorescent or photofluorescent photofluorographic screens. So, recent advances in technology have resulted in introduction of many new number of phosphors, like we have cesium iodide, which is used in image intensifying tubes. There are several new intensifying screening phosphors like barium strontium sulfate, yttrium, or some rare earth elements like gadolinium and lanthanum. So, these are newer intensifying screens which are barium strontium sulfate, yttrium, gadolinium and lanthanum. Thank you.